All right, today is lesson 1.5. We're going to learn about negative exponents. You can put today's date on there. Negative exponents, when you're dealing with them, what we're going to do is flip negative exponents, and then it makes them positive. This piece is very important, and I'm going to show you why that really we just end up flipping them. Okay, your first example looks like something we've already done, right? This is the quotient rule since we're dividing exponents. I want you to expand it out. So there's x to the 4th power divided by x to the 7th. And remember that x is the same number everywhere you see it. So a number divided by itself would cancel, make a 1, 1, a 1, a 1. So I have nothing left in the numerator. Everything canceled out to make 1. In the denominator, I'm left with x to the 3rd power. Okay, but what our quotient rule really says is to subtract powers, and it really should go in order from top to bottom. Now, I told you I don't normally do that. I just subtract and I see where the bigger number is. To me, that's faster. But if I were to subtract 4 minus 7, that's not 3, that's negative 3. So if I did it the shortcut rule way, I would get x to the negative 3rd power. Well, these two things are equivalent. So I want you to see that when you have a negative exponent, you're really going to take it to the bottom, and now it becomes a positive power. And then we have to put a 1 as a place filler on top. So it's 1 over x cubed. Okay, so these things are equivalent, or they equal the same amount. So on this, I wanted you to see that, hey, you might be given something like this. You immediately need to know, I'm going to flip this or sink it to the bottom to be x to the positive 3rd power. And that's how you fix it, because they won't want you to have any of your answers with negative exponents in it. And something funny, I'm getting a little bit older, but surely you guys know who Snoop Dogg is and his song Drop It Like It's Hot. If an exponent's got a negative, drop it like it's hot, drop it like it's hot. Yeah, there's my singing skills for you. Okay, so the next section says to simplify the following expressions using only positive exponents. Okay, so we've got some rules in here. What you're wanting to do is to simplify your top and your bottom, and then we'll do the quotient rule. So on the top, I want to do this part first. X cubed times x squared. Remember, that's our product rule where we add the powers. So that really means x to the 5th. 5 x's are getting multiplied together, divided by x to the 8th. So you could do your quotient rule of subtracting 5 minus 8, which would be x to the negative 3rd, and then flip it. Or you could do what I say I do and just take 8 minus 5, but I know the bigger number is down in the bottom. So that's why x cubed is down here. So we got the same answer that we got in our examples. All right, number 2. There's always several different options to exponent rules. The way I think I'm going to teach it is to flip it. Yeah. So anything you see that has a negative power, I want you to move it. So something I didn't talk about is, yes, if you have a negative exponent, you can sink it to the bottom. The same is true as if you have a negative exponent on the bottom, you bring it to the top. So this division bar here, this line, it's kind of magic. It changes it to be a positive exponent when you flip it. Okay, so I'm going to take this and move it up. So it's x cubed. This is going to be times the x to the 8th. And I'll move this up. So it's times x to the 6th. And then I'll write it again so you can see it a little better. So I don't have anything in the denominator anymore. It's just over a 1, which I don't need to write. Our product rule says to add 3 plus 8 is 11, plus 6 would be x to the 17th power. Okay, I want you to pause and try number 3 on your own. Okay, your final answer should be 1 over x to the 4th. I moved x to the negative 8th down, did my product rule, which is to add the powers, and then there should be x to the 4th in the denominator. Something else you could notice, that you could do your product rule first if you wanted to. Negative 8 plus 8 would be x to the 0 power. Just so you know, anything to the 0 power is not 0 like you think it would be. It's actually 1. So that would be a 1 over x to the 4th. All right, the next three problems get a little trickier just because we have two variables. We have x and y, I guess minus this problem, but this one and this one have x and y. You're going to do the same thing. Move anything that has a negative power. So this one will have nothing on top, so I'll put a 1 there. I'm going to put x's first. It'll be an x to the 4th times x to the 4th times y to the 6th times y to the 8th. That'll become 1 over x to the 8th, y to the 14th. Always put your variables in alphabetical order. Okay, number 5, you should be able to pause and do. I flipped my negative exponents and then did my product rule. I end up with x to the 4th. Okay, and then the last one you should be able to do too, because that's like number 4, so why don't you try that one. Alright, so these are going to flip. You should have an x to the 8th on top over an x cubed. And then this will go to the bottom. So you get y squared times a y cubed, which becomes 8 minus 3, which would be x to the 5th on the top. And then that is product rule. You'll add 2 and 3 will be y to the 5th on the bottom. You cannot cancel these out to make a 1 because x is most likely a different number than y. So taking this number to the 5th is different than this number to the 5th, or different values. Okay. Next section is actually even easier. It says write the following expressions without negative exponents and without parentheses. So top 3 don't have parentheses, but the bottom 3 do. On number 7, the only part that has the negative power is x. The 2 is not connected. It's just a 2 times whatever x to the negative 3rd power is. 2 really has a power of 1 because there's nothing behind it. So the 2 is going to stay in the numerator. The only part I need to fix is this exponent. So it'll sink to the bottom and be x to the positive 3rd power. And that's it. Right, number 8, I'm trying to trick you. This 5 has a negative in front of it. That doesn't mean that it has a negative power. It's still to the 1st power. It's just that the 5 is negative. So the negative 5 stays in the numerator. The only part that needs to be fixed is the x squared will sink to the bottom. Okay, and then I want you to pause and do number 9. So get negative 8 over x. All right, next 3 are different. We talked about because they have parentheses. So this time, this 3x being grouped together in parentheses with the power on the outside applies to all of this. So I need to make this not be a negative exponent or power. So I'm going to have to put a 1 over 3x to the positive 1st power. So it's like I'm writing this again, but I'm sinking it to the bottom and making the power positive. Well, anything to the 1st power is itself, right? 3 to the 1st power is 3, x to the 1st power is x. So really this is just 1 over 3x. All right, number 11, we've got everything to the negative 2nd power. So I'm going to put 1 over the quantity, the amount 5x to the positive 2nd power. And I do need to simplify this. So remember our power rule says I need to have 5 squared, which is 25, and then x squared is x squared. All right, and then number 12, you could try it if you wanted to. The whole thing is to the negative 3rd power, so I'll put 1 over negative 4x to the positive 3rd power. Negative 4 cubed. Do that on a calculator if you wanted to. Put parentheses around it. Remember that little up arrow key is right here? That gives you an exponent of any value you want. Cube it, that is negative 64, and then x cubed. You can keep it like that. I really don't like negatives in the denominator. I would probably float it up and say it's negative 1 over 64x cubed. And that's it.